Hello, everyone. So, as was just said, we're all here today to talk about productionalizing code. So how to turn our lovely notebooks and models and all of that good data science work into production models that can then be deployed and used by all of the lovely people who want to use them. I'm a data scientist. I work for a company called ShopRunner. We're based out of Chicago. We're an e-commerce company out there. We like to think of ourselves as Amazon Prime for everyone else. So we partner with about 140 different retailers, a lot of kind of high fashion places, everything from Saks off Fifth to Neiman Marcus to a really wide array of brands and an ever-expanding kind of product array as well. And then we have a network of millions of members who are, as part of being a member of the ShopRunner network, are offered free 2-day shipping, free returns, and deals across our retail network. Our retail partners offer our members these deals because they get all sorts of benefits from being in our network, everything from connections to all of these awesome members, all of these awesome shoppers, to a really wide array of e-commerce products and tools that we can build that they don't have the ability to build themselves. We're primarily a tech company. We have data on our users across this really wide network, and that where the brands themselves get only a really narrow view of that. They only get a slice, whereas we get a much broader array. And as we all know, the best e-commerce tools are data-driven, right? They personalize experiences to particular users based on what the users have told us about themselves. And as a data scientist, I focus largely on these tools that are data-driven, particularly using models. And we use these tools to help kind of build a delightful shopping experience all across this network. So some of the kind of data science products that we've built and or are kind of in the process of building are kind of some of the things you see here, all designed around connecting shoppers with the retailers and the products that they will be most interested in, that they would want to know about. So we do things like anomaly detection to find trending products at different retailers. We do product recommendations of a couple of different varieties. You can do kind of visual search tools. That's what this bottom array of products is. You give it the product on the left and get back an array of similar products. Our more recent initiatives involve a lot of tools like computer vision and natural language processing, which allow us to kind of learn a lot more about our retailers' catalogs, what kinds of products they offer, and in order to kind of help enrich these connections. So today, though, we're here to talk about this process, right? How to go from a particular business need, a particular goal, all the way to a production model. So this is a very idealized version of what this life cycle might look like, right? We start with some sort of need. We do some data exploration. We say, like, yes, OK, we have this data available. Maybe we need to go get a little bit more over here, but we can wrangle all this together. Then we build a model. We say, OK, we have some ideas about how this might fit together. So we can kind of put these pieces together, train a model, get some predictions out. Eventually, we find a model that we feel pretty good about. We like how it's looking on offline metrics. We're doing pretty well. And we say, OK, now we want to take it to production. So you're going to push it to production. Great. All of you who have worked with data before, you know that it really is a lot more complicated than that. Every time you go through one of these steps, you learn something new. And that makes you need to go back and revisit other pieces. And there's not really this is not a one-directional path. We want to be able to iterate and move around between all of these different pieces. So we're focusing here today on this last piece, on this production step. And we're going to talk a little bit about what I mean by that. But we want to make sure, as we talk about it, that we're not just talking about a one-way process. We're not just talking about a one-time movement from put this model in production, but that we're enabling the ability to iterate on all of these processes, to learn more, to come back, to make things better, and to have that all kind of smoothly flow. I don't know about all of you. To me, this part that I've grayed out here is kind of the fun part, right? Like it's a lot of fun to play around with the data, to build models. That's why a lot of us got into data science, for the data scientists in the crowd. But we're here today to talk about the part on the right, in part because we want to be able to make that part of our process as smooth, as easy, and as fast as possible so that we get to spend more time on the other pieces. So we're going to focus on this production piece, this tooling piece, and kind of how we've tied all that together in order to make that process really smooth and easy. To walk through our process at ShopRunner, we're going to use the very important business use case of classifying whether a picture is a cat or a dog. This is definitely a real business problem and not at all an excuse to have cute animal pictures. So when we start out, we want to be able to go through this exploratory phase. So this is the fun part that I grayed out, right? We're going to do some wrangling of data. We're going to play with different models. We're going to talk to our business liaisons, our product managers, whoever asked us for this model. And we're going to use kind of a fairly standard stack of tools to do that. Because we're dealing with web-scale data, we process over a terabyte of data each day, we need to be able to use distributed techniques. So we use Spark, as I'm guessing many of you do, given the conference that we're at. And so we use we use Databricks as a platform to do that. And then we use your standard kind of data science tooling, so Python, scikit-learn, a variety of other tools that are all kind of part of that standard data science stack. And when you do that, you get kind of a set of notebooks. These are some snippets of data science, of Databricks notebooks, of me playing around with this cat-dog classifier. So you read in some image data. You have your nice data frame of images displayed there. I'm running it through just a ResNet off-the-shelf model to get some features from my cats and dogs images. And then I just trained a simple scikit classifier on top of that to get labels. And cats versus dogs is a fairly easy computer vision task. So we're doing fairly well. I ran through about 5,000 examples, and I'm getting about 35, 40 of them wrong. So that's not too bad. OK, so we have a model. We like it pretty well. Now we want to put it in production. So what exactly does that mean, right? Because what we have right now is a set of notebooks. And what we want is some sort of place that somebody else can come and use this prediction that I have. That can mean a lot of different things. Depending on your use case, it's going to look a little bit different. But there's actually a number of steps between where we are right now and where we want to be. There are many ways you could divide this up. The way that I've divided it up is into kind of 3 sections. One of them is making our code, which is this set of notebooks right now, into something that's more maintainable. So we don't want at some point, something's going to break, right? Because none of us are magical coding people who never break anything. And we want our best chance possible at being able to fix that easily and quickly and not have to go digging through notebooks and trying to figure out environments and all that good stuff. We need to be able to schedule jobs. So there's going to be some processes that work well in batch, whether this is training jobs, ETL, maybe it's scoring a whole bunch of things and putting scored results somewhere. And we're probably going to want some APIs. So we're going to have some use cases where somebody wants to give me an image of a cat or a dog, and they want back a label that says this is a cat or this is a dog. And kind of a standard way to do that is to set up a RESTful API. So we're going to walk through these 3 steps. On the maintainable code front, we're going to do a couple of things. We want to turn our scripts into something more modular, something more kind of better code for whatever that means. For us, that often means turning it into functions, maybe classes, depending on how everything is set up. There are lots of kind of levels at which you can do this, but basically trying to move it towards something that's easier to understand. Maybe you add some doc strings if you're feeling really special. And then that makes it easier to go to the next step, where we can do things like code review. Code review is super important for 2 reasons that I like to call out most frequently. One of which being that it makes your code better, right? Because other people find mistakes that you didn't see. They have suggestions for other ways to do things. That's always great. But just as importantly, it also helps share knowledge around. So at my company, there's frequently kind of one person who's kind of driving a project, because we're a reasonably small team. There's a lot of things we're trying to build. But you don't ever want just one person to know how that model is built, the data that goes into it, how to run it, all of that good stuff. One of my coworkers is building some really cool attribute models, so you can kind of label dress as kind of what length it is, all kinds of things like that that are useful tags to have. But if he goes off on vacation and that breaks, one of us needs to be able to fix it, right? And code review is kind of a good baseline step to making sure that other people have at least looked at the code and have some idea how it works. And then you start getting to things like unit tests, continuous integration. So continuous integration is basically a tool. We use Jenkins. You might have heard of things like CircleCI, Travis, other tools that do the same thing, that automatically run your tests. They can do style checks. They can run linters, all of that good stuff. It kind of helps you have to not, so you don't have to think about that stuff as much, and the tool kind of takes care of it for you. This is never going to catch everything, but it catches enough that you are much safer than you would be without it. So setting all that stuff up is kind of painful. Going from that notebook and setting up all of that infrastructure, you need a whole lot of YAML files, you need a whole lot of configs, all of that good stuff. One way that we set up to make that smoother was to use a generator. So this is an example of a Yeoman generator. We used Yeoman because it was kind of what some other teams at our company were using. For Python data science folks, cookie cutter is a more common example. It all does the same stuff. You basically give it a couple of parameters about your project, which is what you see on the left. And then it generates all of the files for you. So all of this is standard stuff where you just kind of need to plug in a couple of names of projects and stuff in different places. So that's stuff that code is really good at and humans are really bad at. And the whole point of all this process is to let code and machines do the things that code and machines are good at, and let humans do the things that humans are good at. So once we do this, we can pull our code that did all of that fun machine learning into some functions. We can run our tests, and we get the beautiful green lines that mean our tests are passing. And then we can put all of this, this clip on the bottom right is a clip from a Jenkins file. So that's our CI/CD tool that will run all of these steps automatically. So anytime you make a change, it's all kind of runs automatically, and you can see whether you broke anything with your change. And then at the end of the day, we have all of this code on GitHub. So we have a nice new repo. We have on Databricks, then we can import that. We've packaged it up into a library. So we can import this library. And with just 2 lines of code, we have our classifier training and running. So this means that as much code as possible is on GitHub, where it's version controlled, it's code reviewed, all that good software engineering stuff. And we don't have to worry about that anymore. So we're just running a couple lines of code. You may notice the name. My team really likes to name all of our repos after Harry Potter references. So you'll see a few more of those in a moment. So that's the first step. That's writing maintainable code, kind of moving it into that production-ready stage. Now we want to be able to schedule jobs. So Databricks has a feature that lets you schedule Spark jobs, where you can make a notebook, you can schedule a job, and then when the time to run the job comes, it spins up a cluster, it runs your job, and it tears down the cluster for you. That's super nice. It makes it really easy to not have to worry about the infrastructure management piece. But we hit a little bit of a snag when we wanted it to talk with Jenkins. So Jenkins is, as I said, our CI/CD tool. When you update a library, Jenkins can go and build an egg for you, can package up your library. But it doesn't, the APIs that Databricks has available to talk with Jenkins didn't do exactly what we wanted them to. And so it was a little bit complicated to update the jobs that we had scheduled with the new version of the library. So the first pass through that diagram is just the first step here, where we just need to create a job and we need to upload it once. That's great. But then once you go through the second pass, when we had to iterate, change some stuff, and deploy it again, it gets a little bit more complicated. Jenkins can build your egg, but then you need to upload it to Databricks. You need to go and find all of the jobs that use that library, and you need to remove the old library and add the new one. So this is what that looks like. So in the top, you can see I'm just changing the version number. I'm just very simple edit. I'm going to make another egg. You can see that appears in our file down below. Then on the right, I'm going to go and create a new library to upload the library. I'm going to drag my library over once I find the right format. We're going to drag this over here. Now we have a new library. We have our new version on Databricks. But now we need to go find the job. So I previously had created a job that runs that notebook that we looked at earlier, scheduled as a job. So I'm removing the old version of the library. I'm going to navigate through here and find the new version of the library. I'll grade this stuff out for privacy reasons, but you know. So there we go. We're done. That took about a minute to do. That's fine. OK. But now think about when we have 20 libraries, and they each touch 10 jobs, and we want to update them regularly. This becomes a super manual process, and it becomes super easy to miss things. So you miss you forget about one of your jobs, you don't update it, and now it's going to break, and that's all super painful. We wanted to automate this. So we wrote a tool called Operate, which links together all of the API calls that were needed in order to manage all of that, and does it for you. So we automate those final steps that were very manual before. So now it looks like this. So I'm going to start with the same thing, updating the version. If you look at the job below, you'll see I've circled where the version number is. You'll see it update in a minute. So up at the top, I'm now making another egg again. And you'll notice that all of these steps are things that the CI/CD tool can do. So now I'm going to call Operate. It's just a little command line tool. I'm going to call upload and update, and we're going to pass it the path to the egg file that we just made. And then in just a second, you'll see that the library down below is updated, and it's like telling you the couple of things that it did. So it uploaded the current library to the new library to Databricks. It updated jobs it found. It pays attention to versions in a way that lets you control whether or not you want it to update automatically. But here it was just a bug fix that we wanted to push through. And then it cleaned up old versions of the library. That's, again, an optional thing. If that makes you uneasy, you can turn that off. Here's just like kind of to give you a sense of what it's doing under the hood. These are all of the API calls required in order to do this. So there's a lot of back and forth, basically. If you're interested in how it works under the hood, I wrote a blog post with Databricks about it. There's lots of details in there if you're interested. We also open sourced it. So if you're interested in using it, check out this repo. And hopefully it'll help you solve some problems as well. If you have suggestions for how to make it better, we love pull requests. We even love issues. If you want us to try and fix something, we'll help if we can. And basically all you have to do is add a line like this to whatever kind of CI/CD tool you want to use. Or you can also use it from your command line if you're not quite there yet. And it solves a lot of those kind of communication problems that we were having before. So now we've gotten through our jobs, right? We've scheduled our jobs. We've made it easy to update them. That's all looking good. Now we want to be able to use APIs. So this is for the point where having all of the results in a database somewhere isn't good enough. You have somebody who wants to access them in real time, who wants to be able to give you an ID and get back recommendations or whatever process you need. So the exact infrastructure here, the exact structure of what all this looks like is going to vary by use case. We have some places where we actually have a model and featurization tools and all of that loaded in an API, and you can give it an ID, and it goes and does all of that for you. We have other cases where we do the scoring in a batch job offline, because it's not a super time-sensitive project, so it's fine for it to be a day stale, a couple hours stale, whatever. And in those cases, when you call the API, it just checks the database and pulls out what it needs. Depending on your infrastructure, your needs will shift a little bit there. But basically, we build a Flask API, we put it in a Docker container, and then we deploy that through our kind of standard production pipeline. For us, that's using a tool called Spinnaker to deploy on a Kubernetes cluster. But what exactly that infrastructure is going to be different places. But it was really important to us to be able to just kind of use our company's standard pipeline, because then when our DevOps team does their amazing work and goes and improves and upgrades all of that, we can just kind of be along for the ride. And we don't have to spend a lot of time as data scientists worrying about what all that infrastructure looks like. There's just a little bit of startup to set up that pipeline, and then you're good to go. So for our cats and our dogs, our very important use case here, this is an example endpoint in a Flask API. It doesn't have to be Flask. There's all sorts of tools to do this. Django is another popular one for Python. We like Flask. We mostly need very simple things, and Flask is really good at that. But so we're just defining an endpoint. Here, I'm just expecting an image vector, so the pre-featurized image, and then passing it through the model, and returning a label of if it's a cat or if it's a dog. So we can take our images, and we've got our endpoint at the top that asks if it's a cat or a dog, and you can pass in the image name and the vector, and you get back some predictions. Amusingly enough, my model seems to think that any creature that's like peeking out from a small thing is a cat. As a cat owner myself, that kind of tracks. There's probably a lot more pictures of cats hiding in weird places than there are of dogs hiding in weird places. But for the most part, we're doing pretty well. So at this point, we've moved all of this exploratory code into a Python package. We have it code reviewed. We've tested stuff. We've got stuff in version control. There's kind of a single source of truth for the code that's in production. We've scheduled a whole bunch of batch jobs, so that's really awesome. We can do all of our scoring, all of our ETL, all of our training, anything that needs to happen on a big Spark cluster that's going to take a while that we want to do that doesn't need to be immediately fresh, we can do there. And we can deploy an API. So we now have our API that you can pass an image vector to at this point. If you were feeling fancy, you can also do the featurization piece there as well. That's how our actual image services work. I just didn't feel like implementing that in my spare time here for this demo example. But you have your API where you can call with that kind of identifier, that product, and get back your answer. But if you remember, we talked about the fact that we don't just want to do this once, right? We need to be able to go back and iterate and update our models, add new features, do all of this good stuff. So we also have this process now built in that lets us loop through it. So we can do all of our standard GitHub flow. We can do branches, we can do pull requests, get our code review there. All of that infrastructure exists on GitHub. It's super great at what it does. We have Jenkins hooked up. Jenkins is super great at what it does. It does the it mostly does the CI piece for us at this point. We used to use it for CD as well, and recently moved to Spinnaker for that piece. But it kind of handles that piece for us. That's all set up. So when we make changes, that propagates through. We have app-rate set up in Jenkins as well, so that any changes there propagate through to Databricks and update all of the jobs there as needed. And then we have Spinnaker set up so that when we make changes in our repos, API updates propagate through there, and new versions of the APIs deploy there. So we can now walk through this whole process really smoothly and repeat these pieces as needed, which gives us the freedom to really explore and iterate and build out all of the tools that we want. So that's pretty much the structure of what we do. That's kind of how we have it set up at ShopRunner. But I wanted to take a moment to talk through kind of the things that we learned in this process. So I started at ShopRunner nearly 2 years ago. At that point, there had only been data scientists at ShopRunner for a few months. We were kind of just getting off the ground on data science. And so there was really, at that point, we only had notebooks, right? We just started to explore, to build out, to learn what data we even had. And we're just getting to the point where you could start to build things that were going to be useful in production, right? So we've iterated a lot on what this process looks like over the past 2 years. And I think one of the really useful things to me about how we've set this up is that we've really tried to take advantage wherever we can of existing infrastructure at the company and the kind of using tools that are really good at what they do, without trying to find a single tool that solves all of our problems. So there are a lot of kind of managed solutions out there. Some of them are really good. Some of them are great if that's exactly what you need and if you don't have kind of the in-house expertise to build all of the pieces out. But they kind of lock you in, right? There's less flexibility than there is when you kind of spin your own. But also when you get too far into rolling your own, right? You can swing too far the other way, and you can try to build all of the things and kind of corner yourself a little bit. So I think trying to nail that balance is really important. And for us, that balance has really been to take advantage of these kind of best-in-class pieces where we see them. So using things like GitHub, we're not going to do any better on code, like managing code or managing version control or any of that. Like, they've got that covered. Databricks is really good at cluster management. Like, they've really got that nailed and can do all of kinds of optimizations and safeguards and all of that good stuff that were really hard to do on our own. that's one we actually tried a little bit, right? When we first started using Spark, we were kind of rolling our own and spinning up clusters raw in EMR and running Spark on them. And it was a huge kind of DevOps investment from the data science team, which was just really not the best use of resources. So once we moved to Databricks, that kind of cycle got a lot faster, and that was really awesome. But then there's always going to be kind of friction points in the process. One of those friction points for us going through this was when we first started doing the kind of maintainable code piece, right? When we were trying to turn things into libraries, add on the CI/CD, add on all of these things. There's just like kind of a lot of infrastructure, a lot of boilerplate code that ends up in your libraries. And it was so you would kind of copy it from the last library that you did, but then you have to go through and change a bunch of stuff, and you always miss something, and that's never fun. So we were like, okay, this is a little frustrating. So we went and built one of those generators. So I spent an afternoon one day kind of coding that up, and then after that, we don't have to worry about that anymore. That piece is just kind of taken care of. Similarly with Operate, we were kind of just starting down this process of running a lot of batch jobs in Databricks, kind of having our own libraries. So the first time you do it, it's fine. It takes a minute of your time, you're all good. But as you start to scale that out, that became really a friction point. That became really painful and frustrating to have to go and update all of those things manually every time. So at that point, we took a step back and we're like, okay, well, we could probably automate this, right? Like, this is a thing that APIs should be able to handle. So we sat down to figure that out and to kind of make a tool that handles that piece for us. So I think being aware of those friction points and being willing to take a little bit of time, once that piece becomes frustrating enough, to take the time to try to fix it, right? And those are always judgment calls. What is frustrating enough? How much time are you willing to devote to it? But I think we've learned over the past while that there can be real value in kind of taking that time and investing in those pieces. And we're also hopeful that by kind of open sourcing some of these pieces, that we're able to kind of help some other companies, some other groups to ease those points as well, and that we can kind of contribute back to the ecosystem in that way. So thank you all. I am a few minutes early here, so we have plenty of time for questions if folks have them. Just up on the screen here, we have the link to Operate again, if you're interested in checking that out, as well as you can find me on Twitter if you're interested with that. Yes?
Thanks, Hannah. That was wonderful. It was a very good overview. I have 2 quick questions for you.
Yeah, sure.
One is about AWS SageMaker, if you know what that is, and just wondering if you've evaluated tools like SageMaker instead of kind of building your own deployment and API generation and all that. And the second is you started out the presentation saying that you have terabytes of data, and hence hit the one machine limit, had to be distributed, hence you went Spark. But then the very next thing you said was you're using scikit-learn, which is not distributed. So yeah, those are two questions.
Yeah, OK. So absolutely. So for the first question, I didn't catch what the first word that you said was.
AWS SageMaker. So Amazon has...
Sorry. In the first question, asking about...
did you evaluate things like AWS SageMaker instead of...
Yes.
Building your own API generation?
So we did, right? We looked at a bunch of these tools. We tried out SageMaker. It's really nice in some ways, right? But we didn't have the flexibility that we wanted, in part because of when you're kind of in the company, right? You need things to communicate with each other really well. So data science tends to write tools that other teams within our company consume. We write internal services mostly, because the API that I write isn't being directly called by some consumer or some website. It's being called by other internal services within our company, in part because we make them really multi-purpose. So one of the things that I wrote was a similar product search tool, right? So you give it a product ID, and you get back other product IDs that are similar. And so there's a billion places we want to use, that those things are useful within our company, right? We have a customer-facing app. We have a website. We have partnerships with retailers where we build tools on those websites, right? So as data scientists, we don't want to deal with all of those integrations. So the internal tools, we interface with other engineers at our company who call our APIs and then expose those things to the world. So things like SageMaker, we hit snags trying to integrate all of those pieces, and it just became, because that API layer is pretty simple for us, it became easier to just kind of roll our own. The other question was about scikit-learn. I was speaking in generalities there. We do use scikit sometimes for cases. So there are some cases where you have a whole lot of data at the start, and through all of the processing and feature engineering and whatever, the thing that you end up with is pretty small. One case of that for us is that we do kind of similar retailer level modeling, right? Where we want to be able to identify which retailers are kind of tied to each other in our network, because it helps with exploring our network, right, for our customers. We want our customers to know about the rest of our network and those kinds of networks. But when you get down to the actual prediction step, you have 140 things in that model. So that's scikit scale data, right? We also use things like MLlib and the kind of Spark level models. Sometimes we build models where you can train it, where it works to train it on kind of one large machine. If we want to use something fancier than the things that are available in the Spark machine learning libraries, one of my coworkers has done some stuff with fast AI models, with a fast AI collaborative filtering model that he was able to train on one machine and then distribute for scoring, so you can score at scale. So it really depends on the project.
Thank you.
Yeah, sure.
Hi, thanks a lot for sharing your journey. So can we go back to the slide number 32, I think, where you had the high-level steps? Yeah, this one. Yeah, next one. So, OK, just going back to the workflow, you created, like you did experimentation on Notebook, for example, and then once it's ready, you just modularize the code and put it into Git. That's fine. And you did all the code reviews, tested, etc. Now from Git, last step was you deployed it as an app. So like in this whole flow, what are the manual steps? Like, is it all automated or?
It's pretty much all automated. So to kind of walk you through what happens, if I want to make an update to a library that's in production right now, so we have all the pipelines set up, right? Is this fitting? If I want to make a change to it, I make my changes, I implement them in the library, I open a pull request, a team member reviews it, the CI/CD passes, or the CI piece passes, all looks good, we merge it in. At that point, when you merge into GitHub, your master branch there, your CD piece starts to kick off, right? And you update things on Databricks, and you update things in production. We have multiple environments there, so you usually push to you deploy first to a WIP environment, and then sometimes it's a 2-environment thing, sometimes it's a 3-environment thing, depending on how public-facing it is. But so you have kind of a chance. So it's almost a full continuous deployment in its truest sense, but there's a kind of a gate between some sort of WIP staging environment and some sort of production environment. Does that kind of answer your question?
So from Databricks,
yes.
You ran the job.
Yes.
Now from Databricks to actually a running API.
I see. Yes. Sorry for not answering that. Yes. So there's not a direct path in our workflow from Databricks up to an app. The code that runs on jobs on Databricks and the code that is the API is all together in a library on GitHub. And so that when you make a change to that library, it gets updated both places at the same time. So the same process pushes both places. If you need things like you need your job to run with the new version of code before you deploy the new API, you can separate them in ways so that those two deployments aren't the same. Some of our repos have them in the same. Some of our projects have the API piece and the library piece in the same repository. Some of them have them in separate. It depends on how exactly you want to set all that up. But this flow is not exactly the flow of an artifact, or the flow of a model. It's the conceptual flow of how the pieces, the order in which you do things. Does that kind of help?
Cool, thanks.
OK, awesome.
Yeah,
yes?
Thank you for sharing your journey. On the similar lines, so why did you have to update back into Databricks? So are you running the notebook, or the notebook will have the latest packages? So if you can explain, your development is in notebook, and then you do a code generation from the notebook to functions, and then you create an egg, and then you push it back into Databricks. Why should you do that, right? Why can't you deploy those outside of Databricks and?
Yes, so this is for cases where you want a batch, where you have some sort of batch job. So this, for example, in my cat example, is the process that reads in all of your data, trains a model, and saves that model artifact somewhere. And in this case, what I'm doing is I have exploratory code in my notebook, but I want to be able to retrain this model, and I want to be able to retrain the model using this code that I made nice and maintainable. So at that point, this notebook right here, that's 3 lines long, is the one that I schedule as a job. And it depends on this library, and within the library is where all of the magic is happening. And so that's why I want to be able to update and push the new copy of the library when I've made changes to the library, because the library itself, the packaged up library, is what has my production code in it. So code that's just raw written in a notebook is usually not production at our company, because that makes us uncomfortable with version control.
So, but where is the source code for the library? Is it back in Databricks, or is it?
It's in GitHub.
But the original code was developed in Databricks?
So the exploratory work was done in Databricks, but then we took it out of Databricks and made it functions and made it more maintainable.
Okay.
So the code is developed in Databricks, and then we come down to our own machines, make it nice, make it pretty, make it functions, package it up, and push the package back to Databricks with the production code.
So that's, at this point, this notebook is just a wrapper for.
Exactly,
Okay.
exactly. It's just there to call that library.
Okay.
So if this were Scala code, you would just have a job that ran the jar.
Yeah.
But because that's not really a thing with Python, you don't just, it's not set up to
Submit
just
as
run
a
the package
job.
that way. This is our best attempt at that.
Right. Thank you.
Yeah, sure, thanks.
Peter?
Yeah, go ahead.
Hi, Hannah. Thank you very much for the amazing talk. I have a question about job scheduler. Currently, it seems like you are using the Databricks own scheduler, right? So have you considered about others such as Airflow or something integration?
Yeah, so we have talked about it. We haven't done that yet. I think it's not quite an either-or situation, because the scheduled jobs do all the cluster management piece for you, which is really nice. And your scheduled job nodes are cheaper than your interactive cluster nodes and all that good stuff. We want to use those where we can. There's definitely a case for managing the workflows in something like Airflow. We're just kind of starting to hit a point where there are enough dependencies between our projects and between our things where that's starting to become a point of frustration. And I would not be surprised if we move to something like that in the future.
Okay, thank you.
Yeah, sure, thanks.
Hey, Hannah, thank you. I have a quick question for you. So do you experience any latency issue for your API calls, or what is your SLA?
So for the APIs that we build, this is a thing that's going to vary dramatically by product. So we have some APIs that, so for example, our product recommendation API has, or one of them, but it's our API that takes a product and gives you back similar products, as an example. Yeah. The similar products don't change dramatically minute to minute, right? So we score all of those as a batch job. Every so often, we shove them in a database, and so our API is literally just taking a doc ID, or a product ID, calling our database, pulling it out, pulling the results out, and returning them. Those have really, really low latencies, perfectly fine for kind of most any application. We have, so for example, another product that we are is still in development, is working on taking images and taxonomizing them. So saying this is this particular type of shirt, or this is women's jeans, this is whatever. This is a really hard problem because we get feeds from a whole bunch of different retailers and they all have different taxonomies, and we need to put them all in kind of one unified one. But I have some coworkers who are working on this product, and at this point they have an API, it has a model in it, So at this point, there's a lot happening in that model because it's taking in an image, it's running it through a neural net to get features, to do this classification. Like, it's a lot of stuff. So it's not going to be millisecond latency right now.
Okay.
But right now, that's OK, because what we do with it is we run our products through them when we get them, and then we put that result in a database that's super fast for indexing. So like, depending on your solution, exactly how you get to it is going to be different. But usually your bottleneck for these guys is going to be if you're doing a lot of really intensive machine learning within the API, is hard. It's a thing that you can solve in different ways. But we've mostly not really gotten to that yet, because we've mostly been able to kind of get around it.
Okay, thank you.
Yeah, sure. I think we're about done. If you have other questions, I'll be in the hallway for a bit. Thank you for listening.